Hello everyone, welcome back to Infinity Physics. In the last lecture, we had a discussion about relative refractive index, and I have asked some question, and that question was correctly answered by Charmi. So congratulations, Charmi. And in this lecture, we will discuss about lenses. So why we need to study lenses? Because you see many things on your screen, right? And in all these things we are using lenses, and now to make that instrument better we need to study lenses. So what are the basics of lenses and where are they using in our day-to-day life? Let us see. So here in the telescope we are using convex lens. Here we have microscope where again we are using convex lens. Here binoculars, then camera, then specs, then our eye, right, and eye lenses. So in all this case we are using convex and concave lenses. So here many of the things are given where we are using convex lens. Now my question is where we are using concave lenses. Okay, so that is the question. So please, if you know the answer, you can give the answer in the comment section. We will discuss the only about two types of lens. One is a convex lens and another is a concave lens. Mainly there are other types of lenses such as plano-convex, plano-concave, right? But we are not going to discuss about that kind of lenses. Okay, we will only discuss about two types of lenses. One is a convex lens. This is our convex lens, and which is also known as biconvex or double convex lens. Why? Because you see here the surface is like this. From one side it is convex and from the other side also it is convex, right? So as from both the side it is convex, so it is also called biconvex, double convex, or only convex lens, right? So this lens is actually like this. So if you use in the specs it is like this, if you use in the telescope it is like this. So if you touch here, if you touch on the surface, you will find that something is bulging outward. So that type of surfaces are called convex surface. Similarly here you can see that the lens is like this, it is bulging inward. So this is also a concave lens. And if you touch here, this lens is a concave lens. If you touch here on the surface, you will find that it is bulging inward, right? So this type of lenses which is bulging inward have cave like surface are called concave lenses. So if you pass the ray, if you pass the parallel ray from the convex lens, then after refraction from the lens they will meet at a point. See here, they are meeting at a point. So that point is called principal focus, and the distance between the center and that point is called focal length. And here you can see that the rays are going to converge, and hence it is also known as converging lens. In case of the concave lens, if you pass the parallel rays, then after refraction the rays diverges. See here, the rays are diverging. These are the actual pictures. So rays are diverging. Hence the concave lens, it is also known as diverging lens. Now if you trace the rays back, if you trace all these rays back, then you will find that these rays are meeting at this position, right? So here the rays are diverging, so it is called diverging lens. And the rays, the divergent ray, if we trace back, they are meeting where the object is placed at that side, right? If we place the object this side, then the rays are meeting towards left side, and hence it has a virtual focus, right? The rays are not actually meeting, we are tracing them back. So the focus, the focus or the focal length of the concave lens is a virtual, because in case of the lens we always place the screen towards the other side, right? One side there is an object and other side there is a screen. Here in the same case, if we place here object, then we will place screen here. So here this side, the images on the right of the lenses are always real, and images on the left of the lenses are virtual. In case of the mirror it was opposite, right? So remember this thing. Now, so it's a simple representation of the convex and concave lenses. Here you can see that the convex lens, it is also known as converging, and it is called biconvex because it has two convex surfaces, while this lens is a concave lens which is also known as diverging lens because it has two concave surfaces. Some basic terms that are related to spherical lenses. It is also known as spherical lenses. Why? See, other types of lenses are there. Cylindrical lenses are also there, right? So again, there is a question for you that in the comment section, what are the types of lenses? Right? Total, what are types of lenses with a list? You can answer in the comment section if you want. Okay, it is not compulsory. Now, if we assume that these lenses are made up of sphere, for example, here I have one sphere and here I have another sphere. So this lenses, if I cut this part and this part, then what part I will remain with? Then I will remain with only this part, right? So this part looks like a convex, and if this part is made up of a sphere, then it has a center here. Similarly, if this part is made from a sphere, then it has a center here. Actually, they are not made from sphere, right? We just assume that they are a part of a sphere. So here, if it is made from a sphere, then it has its center, which is known as center of curvature, like in the case of the mirrors. Similarly, here it has center of curvature. So in case of the lenses, we have two center of curvatures, right? And in case of the mirrors, we have one center of curvature. So here again, the convex lens is made like this, right? There are two spheres separated by some distance, and if you see this space, then this space acts like a concave. If you cut all this part, then what we are remain with? We are remain with only this part. So this structure we are remain with. So it's like a concave lens. It's like a part of a sphere. So it has center and it has also its center. So here this first lens is a convex lens whose first part, see here, the first part is this, right, where the light will going to incident. So light will going to incident at this position first on this sphere. So this center as here represented as a center 2, but actually if you move in the higher standard, you will represent this part as a center 1, because the ray is going to first incident on this part which has a center towards the right side, and this focal length is f1. Similarly, then the ray will going to incident on this part, then it has center C2 and focus f1. But for our class, for class 10, it is okay if we represent like what I have given in the picture. This is all you also know this, right? R is equals to R radius is equals to 2f. So here instead of center of curvature, we can represent as 2f, right? So instead of writing C, we can write 2f, 2f1 or 2f2. So in your book it is represented like this. Similarly, the center of the lens, not the center of curvature, right? The center of this part, the center of whole part, right? The center of this part is known as optical center. And you all know that other thing, focal length, radius of curvature, principal axis. Okay, so I'm not going into that. Then aperture, this length of the lens or diameter of the lens, this part is called the aperture. Then similarly for the concave lens, but for the concave lens, here light is going to incident on this surface first. So this part has center C1 and focal length f1, and the other part has C2 and f2, right? And radius of curvature. Again, this distance is called 2f1 and this distance is called 2f2, right? And other things are same. Now let us move to the next part. Now we know that we will get some images, right? Now to get some image, we need to locate the image by using some rules that again we are using. Last we were used in case of the convex and concave mirrors. So in case of the lenses also there are some rules to locate the image, right? So where we will get image? Now to locate that image, we have mainly 3 rules. Rule number 1 is when a ray of light from the object parallel to the principal axis of a convex lens pass through the principal focus after refraction from the convex lens on the other side of the lens. Simple, in my words or in scientific words, if I can say, if you direct a ray parallel to the principal axis, in case of a convex lens, then after refraction it will pass from the principal focus. Very simple. Now in case of a concave lens, if you direct a ray parallel to the principal axis, then after refraction the ray will diverge from the focus because it is a diverging lens. In the second slide we have seen that, right? Okay, when you direct the ray towards the concave lens, the ray diverges from the principal focus. So here the ray is diverging, right? And again, what is the rule number 2? It is similar. Now if you pass the ray from the focus, see here in the first case you are passing the ray parallel, then it is going from the focus. Now what if you pass the ray from the focus, then again it will go parallel. So rule number 2 is similar, right? Similarly here, if you direct the ray, see here, if you direct the ray, right, we are thinking of the opposite case. Now if we direct the ray towards the focus, then after refraction it will go parallel. So here we have rule number 2. If we pass the ray from the focus, then after refraction the ray will go parallel. Similarly, if we direct the ray towards the focus in case of a concave lens, because it is a diverging lens, so if we direct a ray towards the principal focus of a concave lens, then after refraction the ray will emerge parallel, right? And third case, and which is very simple, in both the case it is very similar. A ray of light passing through the optical center of convex and concave lens will emerge without any deviation. Means the ray will not deviate at all. So here the ray is directed towards the center. So after refraction it will go without any deviation. It is like in the case of the center of curvature in case of the concave and convex mirror. If you direct the ray towards the if you pass the ray from the center of curvature of a concave mirror, then after reflection the ray again traces back the same path. Here the ray is refracting, that is it is passing but without deviation. Similarly here, if you direct the ray from the optical center of a concave lens, then after refraction it will pass undeviated. So these are the 3 rules which we are going to use. Again I have a question, that why it is not getting deviated, right? That is the question. Okay, so if you want you can answer. Okay, so image formation by convex lens. Here we will discuss only 2 cases, and in the next lecture we will discuss more cases. So let us take the object at the infinite. So whenever the rays are coming from an object which is very far, we assume that the rays are coming parallel. Now when the rays are coming parallel, we know that in the second slide we have seen that the rays after refraction, they will get converge at a point, and that point is called the focal length, or that point is called the principal focus, and that distance is called the focal length. So this distance is called the focal length. So here, where is the object? Rule number 1 we are using. Object is at the infinite. So rays are coming parallel, they will pass from the focus. So here the rays are meeting at focus, and hence we can say the position of the image is on the other side of the lens at the principal focus, because it has 2 principal focus. So we have to mention it where. As we can obtain this on the screen, right? If we place screen here, then we can obtain the image on the screen, and that image is real, and we know that real images are inverted also. So you will obtain an inverted image and real image of that object, and the size is highly diminished. Highly diminished, it is point like. So here you can see that you are obtaining the picture of the sun on a paper, and you will find that the paper starts burning. See, the diameter of the sun is 15 lakh kilometer. Now when you focus that large amount of energy that coming from the sun on a paper, and the image of the sun is very smaller, then what you are doing, you are focusing a large amount of energy at a single point, and that energy will concentrate at a point, and what you will find, you will find that the paper starts burning. Okay, that we all are doing in our childhood, or you can also do right now also. You just take out a magnifying lens, right? The magnifying lens you are using, it's a convex lens. Just take it out, go in the sunlight, take a paper also, and then try to burn it. In that case you need to focus a very sharp image on the paper. Now this can also be used to find the focal length, right? If you want to find the focal length of a convex lens, we can use this trick also. We will focus that sun on the paper, the image of the sun on the paper, and when you can find, suppose here the image of the sun is there here, right? Now you find the distance between the lens and that image, then you will get the focal length of the lens. And in comparison to object, the size is very smaller, hence it is point like. Now we are coming towards the mirror, right? What we are doing, we are coming towards the lens, not mirror. Okay, we are coming towards the lens from infinity. Now we are coming towards. So now we will put our object beyond the center of curvature, or we can say beyond 2f. So position of the, where is the image we are getting? So let us try to locate. So the parallel ray, rule number 1, after refraction will pass from the focus, and rule number 3, the ray directed towards the center after refraction will emerge undeviated. Now where the rays are meeting, at that point we will get an image. So here we are getting the image on the other side of the lens between principal focus and the center of curvature, or principal focus and 2f. The nature is real and inverted. You can see the image is inverted, and if you place a screen here, you can locate the image on the screen like here. Right? So here we have obtained the image on the screen which is inverted. And what is the size? The size of the object is smaller compared to the size of the size of the image is smaller compared to the size of the object. Now we are ending here. Now in the next lecture we are going to discuss 3, 4, 5 and 6 cases. That is total 4 cases are remaining in the next lecture. So if you have enjoyed my lecture, please give your valuable feedback in the comment section. Have a nice day.